So, friends, welcome to this lecture series of geomorphology. Today, we will going to discuss this coastal geomorphology part 2. So, in part 1, we have seen that the coast is a combination of many processes and landforms corresponding to those processes. Some of the landforms are relict and some processes and landforms they are going on in front of us today. And we concluded that the wave and tide they are the most dominating factor in reshaping the coastal landforms. And along the shore zone the wind also plays important role for reshaping it. So, now the question arises, what is the mechanism of this generation of these waves and tides, and to what extent they can modify the coastal processes and the coastal landforms. So, mostly if you see here this water on the ocean floor, they are under pressure, certain pressure, that is called atmospheric pressure, it is measured at the sea level. So, by increase and decreasing of this pressure, either there will be swelling up of this water surface or there will be squeezing of the system, that is called high pressure and low pressure. So, that means if the atmospheric pressure is high, so that means we are lowering the sea level. So, if the atmospheric pressure is low, we are elevating or lifting the sea level up. So, this type of activities, this type of interrelationship, it is called inverted barometric effect. So, the inverted barometric effect, either it will decrease the sea level or increase the sea level. Sometimes you might have heard in news there is a low pressure occurring at the Bay of Bengal or the high pressure occurring somewhere else. So, this high pressure and low pressure means, if it is low pressure, that means this wave or this ocean surface is swelling up, and the ocean surface once it swells up. So, that means water level increases, and that increased water level it affects the coast. So, water will encroach, the shoreline will move forward towards the land and the water level will increase. So, that means directly it is affecting the coastal geomorphic systems, coastal geomorphic processes. Then as a cyclonic storm approaches to the coast, a series of processes combine to endanger coastal installations and promote rapid geomorphic changes. This is important to understand here. This type of cyclonic effect, sudden increase of sea level and hitting the coast, that rapid geomorphic changes occur here. Rapid geomorphic changes means, when we talk about these coastal processes, we say this the coast is constantly being modified by the wave action. It is the permanent process, but once there is an event of storm activity, there is an event of sea level rise, sudden sea level rise, and this water will encroach to the coast. So, that will rapidly modify this process. However, though it is rapidly modified, but those modified geomorphic system will not sustain forever. It is a very limited time period it will be there, and finally, it will be modified or manipulated by the other processes. So, during cyclonic storms, whatever these changes takes place along this coast, it is in a rapid form. So, you know, if the drop of 1 millibar pressure in the atmospheric pressure, which drops 1 millibar, it increases the water level of 1 centimeter. So, major cyclonic storms, either it is hurricanes, the typhoon, the cyclones, whatever may be named, but these are the named depending upon these areas. Somewhere it is the same cyclone, it is called cyclone, it is called typhoon, it is called hurricanes, like that, depending upon the region. Okay. So, during this cyclonic storm, so these typhoons frequently have a central atmospheric pressure, that is 100 millibar below normal. So, that the general age of sea surface under the storm approaches to 1 meter. So, that means either it is 1 meter drop or 1 meter rise. So, that 1 meter that affects a lot along the coastal zone, because the coastal it is close to the mean sea level and these contours are sparse. So, this area is relatively gentle, it is gentle slope. If it is gentle slope, but sometimes this coastal plain is not gentle. For example, if we compare our Indian west coast and east coast, the east coast mostly it is a gentle slope, plain area, cultivated land like that, but the west coast the steep face of the western Ghat is there. So, that means if that 1 meter rise occurs, 100 millibar pressure drops and 1 meter rise of this sea level rises 1 meter, that 1 meter rise may affect in this much area of the system. However, that 1 meter rise will hardly affect this part, because the surface, the steepness of the slope. So, lower slope region like the coastal plains, that 1 meter rise or fall that affect loss hundreds of square kilometer will affect, or thousands of square kilometer it will affect. So, that means those geomorphic processes which were genetically related, they will shift their respective positions by this shift by this drop of 1 meter of sea level. Even more important is the shear stress of strong persistent wind on the sea surface, actually driving mass of water forward and raising mean sea level by 10 meters along this coast. So, during the cyclone and due to this shearing action of this high speed wind. So, if you see here, this is wind, this is the water surface or ocean surface, and wind is blowing here, this is the shear stress on the surface of water, and finally, we know that gradually the ripples will form, then ripples will converted to mega ripples, and again this mega ripple will converted to waves of high amplitude and higher size. So, that means gradually this persistent wind, due to the shearing effect of the wind on the water surface, it creates this type of waves. So, that means we have the atmospheric pressure which can up and down this water surface, we have wind which can up and down the water surface and compel the water to move. So, if these two factors combine together, that means wind setup is combined with inverted barometric effect. So, this combination effect product is the storm surge. So, storm surge with a shore zone water depth several times greater as the highest normal tide. So, now imagine whenever we are talking about 1 meter rise or fall of sea level, 1 meter rise of water level, it is affecting hundreds of square kilometer. So, if several tens of meters rise of the sea level and the whole water is pushing forcefully towards the land, so that means there is a major damage to these coastal installations. So, geomorphology changes, this coastal setup changes, this deposition, erosion, whatever the geomorphic processes, whatever the geological relic landform or the present landforms that are affected. Waves, by far most destructive product of storm surge, are even more destructive because they move shoreward through water tens of meter more deeper than the normal and break against land. It is not usually attacked by the wave. Here it is understand. So, you see, when we are talking something about the normal sea level, we have decided an area, we have confined area which is known as breaker zone. So, breaker zone, it breaks the waves. So, breaks the wave means the wave height increases, the amplitude increases, the wavelength decreases, and those waves, they are very destructive one. So, now we have increased the sea level of tens of meter and the whole water we are carrying towards the land, and once this whole water, this tens of meter of water is going towards the land. So, it is creating a breaker zone where usually water cannot reach. So, that means much inside the land it is creating the breaker zone, and once the breaker zone is there, this wave breaks apart, it is creating high water level, it is high amplitude waves and low wavelength level, and they are most destructive one. So, major damage inside the land surface, it is created due to this type of breaking of this high waves. So, that means due to the storm surge, due to increase of water level, that water is moving inside the land and it is breaking against those areas where usually not reached by normal sea level and hence major damage causes. So, if it is in a world example is given here, major hurricanes approach the Gulf of Southeastern Atlantic coast of the USA with a particular multi-decadal range variation that has been correlated with drought in the Sahel region of Western Africa. Similarly, in Indian Ocean also, you have Indian examples, you every year you can say the hurricane this, the cyclone naming this, cyclone naming that, they are occurring. And finally, most effect occurs along the east coast of India and in the Bangladesh. So, this Indian coast very large cyclones cause enormous death and destruction of the low lying delta regions, even it changes geomorphology. The Ganga Brahmaputra delta major changes in its geomorphology that occurs during the type of cyclones. So, such storms not only the deltaic part that is affect this coastal plain from starting from the south to north, the whole coastal plain is affected, but the most effect occurs where it hits to the surface, because this is the breaker zone. So, the breaker zones are mostly damaged. Then another reason or another way of generation of wave, it is the tsunami waves. So, tsunami it is related to submarine earthquakes. So, if you see here, this is a diagrammatic representation. If you are creating an earthquake here, from the earthquakes waves are moving upward and finally, it is swelling of this ocean water here, and the wave it migrates this direction and this direction and hits the continental region. But here we have to very cautious about distinguishing whether this wave generated or wave interacting at the coast zone is due to tsunami of wave or it is due to storm wave or it is the normal waves. So, that can be distinguished by careful observations. For example, if you see here, there is comparison given with the tsunami waves and normal waves. Normal waves, movement of uppermost layer of water only, motion diminishes with depth, but tsunami waves, movement of entire water column down to the sea floor, the whole water column is moving. Causes by wind or storm surge, causes by tides of tsunamis or earthquakes, submarine earthquakes. Wavelength is 30 to 200 meter, period is 1 to 30 second, period here is called the frequency, and wavelength if you compare the tsunami waves, it is 80 to 500 kilometer, here 30 to 200 meter, but here 80 to 500 kilometer wavelength, and period is 5 to 60 minute. So, speed is 15 to 115 kilometer per hour, it are 50 to 900 kilometer per hour. So, function of depth only, it is function of wave period and dispersive only. So, that means by careful observation of this nature of this wave, we can distinguish which type of wave is coming from this tsunami and which type of wave is coming from this normal storm surge or the normal level of sea of due to wind frictions. So, as this tsunami wave moves from submarine condition towards the coast, sudden motion of sea floor during the earthquake creates a solitary waves of the most 2 or 3 waves of the very low amplitude that moves rapidly over the deep ocean. That rapid movement, that is 50 to 500 kilometer wavelength and it is 50 to 900 kilometer per hour, that sudden hit along this coastal zone, it is damaged more. So, there are historic evidences, there are geological evidences of tsunami waves, they are recorded along these coastal sediments. Okay. So, that means there are tsunami waves, there are storm waves due to change in water pressure, there are waves. So, that means there are many regions through which we can generate waves in the ocean surface, and that waves they are gradually or suddenly it is coming and interacting along the coast zone, and finally, they are changing the geomorphic process along this coastal region. Because of their extremely long wavelength and low height, tsunamis cannot be detected as they pass through the swell pattern of the ocean floor. As they cross the swelling bottom, the wavelength shortens and the wave height greatly increases up to 15 meter or more, with disastrous consequence when it breaks. So, a 15-meter wave when it is breaking, so its height increases, and those height of wave, it is more than the normal height of these buildings. So, that will damage more as compared to other types of waves. Although violently destructive to coastal inhabitants and their buildings, neither cyclonic storm nor tsunamis see to leave a permanent record of geomorphic changes. So, that is has to be understood here. That means, though they are occurring, they are going far beyond their normal level, but whatever the record they leaves, that record is not a permanent record, because they can easily modified by the other processes. However, those records which are left by the normal waves along the coast zone, they remain relatively permanent as compared to the tsunamis. But tsunami record, they are recorded within the sediments, but their geomorphic changes, they are not permanent. But if we compare these geomorphic changes of floods, the tsunamis, then the other processes, the flood geomorphic changes are more permanent as compared to the tsunami geomorphic changes. So, the recurrence interval are comparable to floods of similar magnitude, but their impact is unlike large, infrequent river floods which may alter a river channel and floodplains to extent that many years of less intense events do not remove the record. So, that means I want to say that the tsunami record or tsunami record of geomorphic changes, not the tsunami record of sedimentation. Tsunami records of geomorphic changes is not permanent as compared to the river changes. Most hurricanes flatten the dunes and other subaerial pattern parts of coastal barriers, where the eroded sand is deposited nearby, either on the near shore bottom or in the lagoons immediately. So, those sands, those which are removed or eroded from this coast, that is transported to a little distance and deposits there. Similarly, during high tide, that material again transported towards coast, again deposits somewhere here. So, that is why the coastal geomorphic process, it is dynamic. The coastal geomorphic changes is dynamic, like this wind system. Wind system, it is a dynamic geomorphic process. Every time, that means in the morning wind and this evening wind, that will change the position of the dunes. Similarly, these sand dunes or the sand ripples or whatever the geomorphic processes involved along this coast region, they also frequently change their positions. The depositional process, the depositional landforms, they frequently change their positions. So, that is why it is the coast zone, it is mostly it is a vibrant geomorphic region, where this frequency of changes of the geomorphic process is relatively more rapidly as compared to other processes or other regions. So, in addition to waves, either it is tsunami waves, it is storm waves, or the waves which is created by these atmospheric changes. So, in addition to the waves, tides and currents also plays their role changing the geomorphology along the coast. Tides are unique form of energy of geomorphic change. Power is dissipated by the tidal drag of the moon and sun of the rotating earth at the rate of about 3 into 10 to the power 9, it will be 10 to the power 9 kilowatt. So, here there are 3 processes, one is river process, one is wave process, another is tide process. So, 3 processes combinedly working along the coastal zone to change the coastal geomorphology. If you see here, each process they have their region of dominance. So, if you see here, it is where river process is more active as compared to this wave and tide, we are getting river dominated delta. If it is wave is more active, that is its beach shore face, then it is tide is active, we are getting tidal flood. Similarly, depending upon the degree of dominance, we are getting tide dominated delta, tide dominated estuaries, wave dominated delta, wave dominated estuary, and here we are getting lagoons, mostly it is wave dominated and near to the beach, and tide does not affect or hardly it affects to this and do not affect these lagoons. So, that means I want to say, depending upon their geographic domains, depending upon the dominance of different agents. So, landforms either erosional or depositional landforms, they form accordingly. Similarly, if you see here, this is open sea and this is this tidal delta, it is tide dominated, this is the marshland, and finally, this is the secondary channels, this is main tide channel. So, the landforms here, either it is marsh, it is tidal flood, it is the deltas or whatever the landforms. Those landforms, they are dominated by a particular type of processes or they are equally dominated, equally influenced by number of processes involved. Similarly, the geomorphic changes or the geomorphic process of a particular landform may be combined of many of these geomorphic agents or may be dominated by a particular geomorphic agents depending upon their positions. So, if it is isolated, then only towards the land river will be more dominant. If it is towards sea, that is wave will be more dominated. In between tide, waves and rivers, they will be equally dominated or reciprocally dominated. Okay. So, that means coastal geomorphology is a combination of many of these processes, they are acting together. The complex period and the height of tides are driven by lunar and solar activity or solar gravity, but are affected by size and depth of various ocean basin. Here size and depth of various ocean basin. The shallow oceans, that will affect differently as compared to the deeper part of the ocean. The shape of the shoreline, this also matters. The shape of the shoreline, either it is a straight shoreline, it is an undulating shoreline. Along the shoreline is dominated by hard rock, hard and compact rock. It is shoreline, it is semi consolidated or consolidated sediment or it is loose sediment lying. Latitude of the basins, geographic position, that means either it is a low latitude or it is in higher latitudes. The warm water current is there or this cold water current is there. Among many variables, these variables like the size and depth of various ocean basin, shape of the shoreline, latitude of the basin and type of rock exposed, all those parameters influence differently to decide what should be the coastal geomorphic processes active there, what should be the coastal landforms will produce there. Okay. So, if you see here, we have the Indian coasts and if you compare this coastal regions of west and coastal regions of the east, this is a digital elevation model and diagram which is artistic diagram. You see there is a sudden change, there is a sudden change in topography, but here there is a gradual change and then there will be a sudden change. So, that means if the same level of water increase or decrease, that will affect here differently as compared to here. So, that means what type of rock, for example, in the Western Ghat, the whole Western Ghat in the western coast is lying as a wall, a hard rock is there, hard compact rock. However, if you compare there, this is mostly alluvium, coastal alluvium covered with coastal alluvium. So, the rate of geomorphic changes along the east coast will be more as compared to the west coast. Okay. Similarly, that is why there are different agents, different processes like here discussed. So, all those factors they combinedly decide what should be the geomorphic process, what should be the geomorphic landforms that will produce along these coastal plains. Seasonal wind and atmospheric pressure pattern also influence the tides. Here tide also is coming into effect. So, not only wave, the tides, there are high tides, there are low tides, some places there are 4 times the tide is affected, some places it is 6 times tide will be affect, some places it will be less than 4. So, that means the geographic position also decide what type of landforms we are going to get. So, tide also influencing the coastal landform of reciprocal manner. Each ocean, gulf and sea has its own tidal pattern. The energy of tide is primarily dissipated by the shallow sea, and hence the coastal and submarine geomorphological processes of shallow seas are strongly shaped by this tidal energy. So, that is why this tide plays important role along with waves to shape the geomorphology of the coast. Most commonly, 2 high tides alternate with 2 low tides each day, separated by little less than 6 hours. This pattern is known as semi-diurnal tide, and some coasts experience only 1 high tide and 1 low tide each day. It is called diurnal tide. Other patterns are mixed or cyclic variable, twice monthly in phase, and the new and full moon are these highest or spring tides it is called. Similarly, during lunar equator phase, tides of less amplitude are called neap tides. So, tides have also different patterns. So, some areas they experience more tide, some area it is experience less tide, and some are frequent tide activities there, some are less frequent tide activities there. So, depending upon this, that also changes the geomorphology, that also changes what type of geomorphic landform will occur there. Tidal ranges are high only where the tide enters semi enclosed sea or gulf that has a shape and depth to produce natural period of water oscillation. That is the region with some period of the tide. So, here very important and example of world example is there. This is the Bay of Fundy. If you see here, there is tidal range is here 6 meter, and here it is 15 meter, and somewhere it is 16 meter. So, that means 16 meter of increase of water level a day. If you see here, these 3 consecutive photograph is there. At once upon a time in a day, you will find this is totally dry region and water level is here. And during tide, see this water level is increasing, that means water level increased from here to here. And similarly, with another photograph, you see these people are enjoying with boats. So, that means here this is a particular place in Canada, here 16 meter increase and decrease of sea level in a day. So, that means water is lifted 16 meter is, that means it is a 3-story building or so. So, that means up to that level water is increasing and decreasing. So, that means this increment and decrease of this water level, that is creating some geomorphic changes, and if you see here these geomorphic changes that erosion is there. So, that means these tidal ranges are high where tide enters through a semi enclosed sea, here if you see here this type of sea, it is entering here, both sides is confined by land. Is this type of geographic setup is there, tide will affect more as compared to open sea. In addition to their primary geomorphic role of raising and lowering this level of wave attack against the land, tides generate strong currents. Tidal currents compete with waves and river currents to shaping the delta. Here, not only these tides act as a lift of lifting this water level or the wave level from here to here, because at the low tide level wave is acting at this level, at high tide level wave is acting at that level. So, tide is acting as a lift to uplift the wave level or to decrease the wave level. Similarly, the wave level is this much, so erosion will occur in this level. So, at the low tide wave is acting at this level. So, erosion will occur in this level. So, that means there is a drastic variation of water level at the erosional level from this level to that level. Tidal current compete with waves and river currents in shaping delta. So, how much tide will affect, how much wave will affect. So, that is why the delta are shaped accordingly. So, here we have two types of photographs, one is wave dominated delta, one is tide dominated delta. If you see the alignment of these depressional systems, here this tide dominated delta is elongated according to this tide, but here the wave dominated delta, the depressional systems, they are elongated according to this wave system. So, this is a funnel shaped system or funnel shaped conduit through which the tide can move. So, rapid currents, they are moving along this during tide, high tide or low tide. These conduits or these river mouths, they through which rapid currents are moving to and fro, and once there are rapid movement of the currents, they changes the river level, this changes the river that is the river base level, and finally, it is changing the geomorphic system. So, that is why this river dominated delta or tide dominated delta, or there will be a combination of that. If you see here, which is river, then wave, then tides. Here this shape of this delta you see, this it is, if it is river dominated delta, we are getting Mississippi delta, it is called Barfoot delta, and similarly tide dominated delta, we are getting some of these landforms you see, they are parallel to this tide, and wave dominated delta, it is due to wave dominated is like this. So, according to this dominance of a process, either it will be river dominated or there will be tide dominated, that depends. Similarly, the landform changes. So, I think we should stop here and we will meet in the next class. Thank you.